Hello, can you hear me?
Yes, I can hear you. Can you hear me?
Yeah, I can hear you properly. Yeah. So now kindly share your screen and then show me your problem which you face. Then I will guide you to solve it.
Okay.
So kindly share.
Okay, thank you. Okay. A minute.
To check the value. We find out the minus 23. Minus 23. So before flood, we find out the minus 23, and after flood we can also get the minus 23. So all of values in this time for the water body we can get here the minus 23. Okay, so you can put here the minus 20 and then check
Mm-hmm.
what happened. Okay, so just instead of the minus 24, instead of the minus 24, just put here
Mm-hmm.
the minus 20 and run the code and then check what happened. Yeah. Okay, minus 20, and also put here the minus 20, and also for the water body minus 20, and also put here the minus 20. Okay, so now run the code and then check it will be show the or not.
Okay. Mm-hmm. Okay, much of the. Let me see.
To me. So in this time it show about that only for that flooded water as a red color
Yeah,
in here.
I can see. Okay, there was on 25th April.
Yeah.
There was lots of floods on different parts of the county, Nairobi.
Yeah.
So I was trying to like visualize the areas which were really flooded, so that maybe I can try to look at the damage assessment from that end. So that was the purpose of, yeah, me trying to visualize the flooded areas.
Okay. Okay. So your time is also okay. Suppose your before flood and after flood, did you check it properly?
Yeah,
Any
I
time?
I put um I put, okay, the after I put the after for 20, after was 25th March and 25th April, like that's the duration I put. And then the before was when there were no rains, which was in December and
Okay.
January.
December, January.
Like the heavy rain started end of March and they lasted till end of April. But
Okay.
actually on this date is when the floods was so bad that many people were really deeply displaced by the water.
Okay. So now you try to put here that suppose year of 2024, take the full month of May. Okay. Put the 05.
Where? Here.
Yeah. 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 So last date after
No,
flood. After flood. After flood,
I
you
just
increase
do it.
increase the time. Okay. From March to May. March to May. So put here the 03 20 25, and then put here the May.
But oh, okay. Which date May? Cause Okay, during May, it's not been much flooded, or I just do it, or I just write.
Yeah, just increase the time. Yeah. Okay.
Okay.
Yes. So now time to check about that. Now show your the map.
Okay, it's done running.
But lower part is not show the flooded area. So this is the problem. The lower part it show only
Yes,
for
because in
this.
the before, yeah, because in the before and after there is the change is there, like the here
Yeah.
the
So in this
change
time,
is
can you check it the what is the value for in the lower part pixel value? Check the lower part pixel value. Yeah. This part. Check the
okay.
pixel value of the water body. Suppose
There
for
is
that.
actually
Uh,
I
there are
think
this
they
type
should
of
be a river. Yeah.
black color pixel. Check about that. What the value? Okay, just click on the inspector tab. Click on the inspector tab and check the value. Then we can easily get it. What is the condition about the before flood and after flood? You find out the minus 23 and check more check. Minus 12. You can get that minus 12 about that. Okay, so now you try to apply here, suppose minus 15 and then try to check what happens. Suppose instead of the minus 20, put at the minus 15 because lower part pixel is also low. Okay, so try to put at the minus 15. All
Okay.
20 just convert into minus 15.
Okay.
Now run the code and then try to check.
Do I also change the display or just here? The visualization.
It's okay, no problem. It's okay, no problem. You try to run the code.
Okay.
Yeah, so now it also take, you can see here, you can get this type
Yes.
of result. Okay. So now it also increasing this type of things. So you can get the permanent water body, this type of color.
Mm,
So increase the lower side. Suppose put here that 16 or 17 and try to check.
Every place which has 15, I put 17.
Yeah.
Oh, I had also asked, is there a way to do the overall accuracy tests, the kappa coefficient?
Run the code. Okay, so for
Pardon?
applying the kappa coefficient, we have to use a machine learning model. So basically, we can use the machine learning model. We classify in the classification. Then we can check about the accuracy using the kappa coefficient
Okay.
or other things. We can also do it for this flood mapping. So for that, you can simply send me your code link. Then I also write the code on your in here, and then you can easily get it. No problem. So
Okay.
now you can see how you can get this type is a permanent water body. You can see as a river or any kind of lake. Okay,
Oh
so
yeah,
this type
I
of thing.
think. Oh yeah, this is actually a river. Can see there is a dam. There is a Bugatti River. Okay. Okay, so I just like share the link.
Yeah, get link. Click on the you can see the copy script path or get link shareable. Just click on.
Oh, okay. This one, shareable.
Yeah, not like
Okay.
that. Just click on the get link button. Get link button, and also anyone can read. Anyone can read. Click on the anyone can read. Anyone can read. Click on the anyone can read. Yeah. Then done. Click to the done. Then copy this link and then send me. Send me in the Google Meet inbox.
Okay.
Got it. So now let me open my code.
Okay.
So now I can stop the sharing. Let me try to open.
Okay.
Okay, can you see my screen? Is it visible?
Yes, let me check. Yes, it is.
Okay, it loaded. So now let me okay. So it show about the neighborhood country is not visible. Okay, so for this you can see here in this time it show about that not found. So for that you
Oh,
can simply click on
let
the
me
asset
let
tab
me.
and then click on your shapefile
I
boundary and
can
then
share.
anyone can read. Okay, click on here and then can easily find out the anyone can read. Click to the done. Click to anyone can read and then click to the done. Then it also okay. Then I can easily access your this Nairobi country boundary shapefile and then run the code. Yeah? So now do it and
Okay.
share it.
I'm just supposed to click the file.
Yeah, click on your shape file and you can see the share button. Okay, or also share button. You can see share button. And further, you can click on here. You can get
Oh,
the anyone can read. Okay, then done it. Then I can easily
oh,
get it. The shape file boundary.
okay.
Can you read? Okay, done. So now I can see this code is opening from my side.
Mm.
Let me run the code again. Okay, so now I write the code for that accuracy, how we can easily check the kappa accuracy or other accuracy using the machine learning
Okay.
model. So just I write the comment from here. Learning
Okay.
kappa. And okay, so finally we can put at that value. I think you did not send me the update code. It's the previous code.
Oh. Oh, it wasn't saved. Sorry. I did not save the changes.
Yeah. So that's why it also now run the code again. Now we can get the proper map, card invitation, and also a permanent water body. Yeah. So in this time, for using the machine learning, we have to use the. We need to take the training sample for that water body, as well also get the training sample for flood inundation. So two training sample we get collect from here, and further we make this flood inundation map.
Oh, okay.
So for collecting the training sample, I just simply click on here, take the new geometry. I put the geometry name is that start, and then put at the feature collection. I set the property suppose class and set the value for 0. So is our card. And now I take this type of flood pixel. Just simply click, take the some training sample because we calculate the accuracy about that. Okay, and then I take the another new layer and put at that it's a water body or permanent water body, right? The water body and feature collection. Basically, it's a what I set the property. It's a class and set the value for 1. Okay. Then I take this water body. Suppose it's a permanent. I simply take this some pixel from here.
Oh,
Okay. So now it's done. Suppose I take this to training sample. So now take a variable, suppose sample, and then I simply merge the flood. It merge with your water. Okay, simply merge. So now further we take
okay.
call our image. So I simply put here the training. So for the training, I just call the imagery. So basically in this time here you can see we are just used at the imagery. This imagery we just put it here. after image, before image, okay? And then further we are just calculate the flood using here water. Okay, so for doing these things, we are just call here of the imagery. From this imagery, and then I use a select function. Select the band. Basically, in this time here you can see that use here the one band. Band name is two band. We are using here PH one band. So PH. Okay. This band we have to in here. So PH band. So PH band, and then use here that this function sample regions. And further I put all of those things one by one. So just I extract the training sample. Okay, so further this training sample I want to apply to check our accuracy for our flood and flood. Uh, so just collection mainly is the sample I paste here. Then properties mainly it's our property name. Is I put the class scale mainly I put at the resolution that was 10 meter. Not remove that. So now it create our training set, training data set. Just need to train and call the training. Copy and paste here. So click to run this time you can see it show you the result for all of pixel. Okay, it execute all of pixel from here. Suppose this type of training sample have a individual level training sample. So now it executes from here. Suppose I put the flood W. I put the unique name here because we already use the flood variable. So flood W. So that image select sample is have some problem in the image. Oh yeah, we have to create that a site composite all of collection. Or we create that median pixel.
Okay. I think invalid type.
Show that March teacher
Collection
0.
2. Have we used collection before?
If I print that sample, suppose I put the water in the different variable, suppose P. Because we already used the variable from the water.
Okay.
Oh, we put the wrong spelling. Yeah, it's the wrong spelling. We have to same spelling. Now
Oh, you wrote small.
so it's
I
now it
hadn't
work. I hope.
noticed.
Yes. Yeah. So here can it work. We draw these are sample. So now I want to use this type of things to check our accuracy. So you can see for that all of value execute from here. So for the accuracy, there are a lot of way for machine learning. I want to use a machine learning. It's called the support vector machine. So just I take a variable. Suppose I put the variable name is the model. So I just call here one model for that
Could you
SVM.
kindly comment? Could you kindly comment on the machine model you're using?
Yeah, yeah. call that
Okay. Thank you.
model. Suppose SVM, support vector machine, and then check what the accuracy we can get from here.
Okay.
Just like copy, further paste here model, and I want to train this model. So just use here the train function and put all of those things one by one. So just make a dictionary. So curly bracket start. Curly bracket end. So first of all, here you can see the some feature. So basically, it's our training feature. Just I say train, and before this model, we have to split the data. Okay? Suppose from this train, we are just applying that 80% data to train
The error
our
matrix.
model,
Okay.
and suppose 20% data to check the validation. Okay? So just I do it. So take a variable. Suppose I put the variable name in the data set and call my training dot random column.
Column. You've typed column wrongly.
Random column,
COLUMN.
and then
Yes.
take the variable. Suppose train set and call this data set. From here, I just filter 80% data. So e dot filter dot greater than randomly 0.8, and take the another variable test set. I call the data set dot filter user e dot filter dot less than equal random 0.8. So we can get the two data greater than and less than equal from 0.8. So now I call the train set and then paste here class property. I put the class property. Suppose I put the class property name as a class property. So just we put here the class property name class. This I already defined. Input properties. So input properties mainly it's our band. So in this time we'll consider the one band which is VH. Okay? VH is our band name. So just I simply use this band name input properties as a bands. This is VH. Just I put here that VH. It's not need, remove that. So now it's create our model. So just I print this model. So you can see we can get this model look like that. So now this model I want to check the accuracy for that our map and also visualize our map. So for doing these things, we just take a variable. Suppose I put the variable name is that flood map, and I call my model. So I call my imagery. Basically, this is my imagery, and from this imagery, I want to choose a band. So just put here this imagery and put here this select this band. Mainly, I put the band name is that TS, and then use a function classify and classify with my model. So now further just add it map dot add layer. So just I want to visualize this result for the part map, then check what happens. Part map, paste here, and I want to visualize it. I just make the curly bracket mean 0 and also put here the max 1 and put here this plated function. Suppose start show as a red color and permanent will show as a color. Now let's check what happened. We have to use here the imagery dot. Suppose take a variable. I put the variable name suppose confusion, and you put e dot matrix, and then call this test set simply connect here, and then add this model. So you get the Copify model. Further find out that error matrix and put out the actual value and predicted value. At this things. The actual value mainly it's our class. Predicted value it can be classified. What are not net. So remove that. Now print suppose in this confusion matrix above. The work is okay, we can get this type of thing. So from here just print the confusion level, and I want to calculate that accuracy, and also I need to print the kappa accuracy here. Kappa accuracy. So now try to check. So now it show you the result like that. We can get that kappa accuracy is that 85%, and we can get that accuracy overall accuracy 92%. Okay, I have to mention about this notation. The kappa, okay, say your overall accuracy. Overall, equal to 1. Then it's computed. So overall accuracy we can get that. Also kappa accuracy about that 47. So after creating this map, it's very easy. Suppose I want to create this type of flood inundation and also create the water body map, permanent water body map. So further, you are just simply take this training sample for that flood water and take the permanent water. Then you just create a model, suppose machine learning model, support vector machine. In this time I use in here. And further, this model I want to extract some pixel value. Suppose permanent water body pixel value, and also extract the your flood water pixel value. Simply extract from here as a pixel value, VS value. And further, this VS value we are just use as in my confusion matrix table. And further, we calculate the overall accuracy and also calculate about that your kappa accuracy. So this is the process about that for calculating the accuracy also. And this thresholding value you have to check. Okay, sometimes you have to check some value. Suppose you can click on here. You can see click on the water body, permanent water body. We can get this type of value. Before water we can get the minus 19. After water we can get the minus 22. Okay. So all of pixel which is greater than minus 19, it considered as a flood water. Okay, so just you can put here that greater than about that. So click on here, you can see. So in this time, we can get the minus 24. We can get that before flood. You can see the before flood minus 14, and after flood minus 24. Okay. So all of pixel which is greater than minus 14, it considered as the flood water. So using this sum consideration, then you can simply put this value in your flood thresholding value, and then we can easily get this type of map. And further check the accuracy. Just take the training sample for flood and permanent water body, and further use a machine learning model, and then you can check the accuracy using the cup accuracy or a wallet. Okay. Okay, I hope you can got this idea. Can you hear me? Hello.
Oh, sorry. I thought I
Yeah.
was communicating.
Okay, so I will send you
Yes,
this
can you hear
code.
me now?
You also try to
Okay.
check it. I hope you can easily get this.
Okay.
Thank you.
Let me try to.
Yeah. Okay.
I appreciate your help. Thank you.
Thank you. Thank you. Okay. Have a good day. Okay. Bye.
Okay. You'll share the code via WhatsApp.
Okay. I will send you.